Okay, let's do the sum rule. F at x equals, I think I was using G and H last time. I'm going to use P and Q this time. I'm getting a little wild here. Yeah. Would you use it? Oh, yeah, just a little. Okay. Where P at x and Q at x are differentiable. Remember, that's necessary. Means able to take the derivative of. Doesn't mean the derivative exists everywhere, but it's the kind of thing that you can take the derivative of. What kind of thing can you not take the derivative of? I don't know, really. Almost every kind of function you can. There's a famous function that is differentiable nowhere. But I don't think this is what this is referring to. I think it's referring to things that are like not functions or something. But anyway.
Does spelling matter?
Yes, you need to learn how to spell differentiable. Just start spelling difference and stop at the right time and spell table with an I in it. There you go. Okay. So f at x is p at x plus q at x. P at x and q at x are differentiable. No constants in this one. F prime at x equals the limit as h approaches 0 of f at x plus h minus f at x all over h equals the limit as h approaches 0. F at x plus h is p at x plus h plus q at x plus h minus f at x is p at x plus q at x. So this is f at x plus h, because f at x is p at x plus q at x. So this is f at x plus h. I sub x plus h in for all the x's. And that's just f at x. That's what we defined it as. Is that okay? It's good so far? What do you think we do now? Thank you. Make sure you expand properly. If you don't get the minus q at x, that's not going to work. What do you think we do now?
You have to show that?
Yeah.
Expanding, can I just skip it?
No. How could you skip it?
Go.
Proofs, you don't mess around. You don't skip steps. You show every step. Sorry?
You can just expand the P into the Q and then cancel out.
Ah, careful. That's a good point. But this is p at x plus h. It's not p times x plus h. So you can't expand that in. What do you think we do?
Limit property 4.
I don't know that we're ready to use limit property 4 yet, but you're on the right track. That's definitely where we're going with this. What do we do? But how do we want to split it up?
You do the x plus h1 over h minus p at x.
Hmm? Anybody have another idea? We need to have the right things with the right things.
Can you split up the P? No.
Oh,
Can you
you
put
put
P
What were you going to say? Yeah, that's right. Put the P's together and put the Q's together. Now I split it. Okay. And you need brackets here because otherwise it wouldn't be clear if you're just taking the limit of the first part or of the whole thing. Whoops, so plus okay. Now, Matthew, what do we do?
I'm going to have to say limit property 4.
I'm glad you said that. Limit property 4 says the limit of a sum is equal to the sum of the limits. So this allows us to go equals limit as h approaches 0 of p at x plus h minus p at x over h plus limit as h approaches 0 of q at x plus h minus q at x over h. Limit property 4. And if anybody's not quite getting what we're doing here, let me show you. This is the definition of the derivative of f. This is what we said. Definition of the derivative. F prime at x is the limit as h approaches 0 of f at x plus h minus f at x over h. Right? Okay. So then what is this? It's the derivative of p, because that's the formula. P prime equals this. If f prime equals this, this is just the same thing, but with p's instead of f's. So now I can write, and you have to do this last step, equals p prime at x plus q prime at x, which was what we had set out to demonstrate. Therefore, if f at x equals p at x plus q at x, then f prime at x equals p prime at x plus q prime at x. Because we went through it a little bit quickly yesterday, so I want to make sure that people understand. And here's the thing, folks. My best advice is to understand that this line here is what you're working towards. You already know the answer. It's going to work out to p prime plus q prime, which means it has to work out to this in the line above it. So if you're not sort of anticipating what you're working towards, I mean, if you just memorize every line, every step, and then just rewrite it, then fine. But if you're thinking about it at all, or if you get stuck, or if all of a sudden I ask you one, and you're like, uh-oh, this isn't the one I prepared for, then that's the best tip I can give you, is think about what the line before the last line has to look like, and understand that's what you're working towards. So like, how am I supposed to know to rearrange the p's with the p's and the q's with the q's? Well, that's the only way you're going to get to this step, is having the p's together in one place and the q's together in another place. So I leave it as an exercise to you to try to do the difference rule. This was the sum rule. I want you to do the difference rule. Okay? It's almost identical, but there is one extra step. And I want you to see if you can get that step. And I want you to try it and think about it before you look at the answer online, because I will, not today probably, but like tomorrow or over the weekend, I will put the proof of the difference rule up online, and you can make sure that you've got it. Sound good?